Hi everyone, thank you for joining our talk on evading Suricata IDS. We are happy to present our project on researching evasion for the SMB protocol. So we are two graduate engineers from Telecom Nancy. I am now a security expert in threat research and analysis. And Louis is now a security researcher at Synactive in vulnerability research and exploitation. Telecom Nancy is a French engineering school, and this project is a research project we made in second year. In order to discover the research and academic fields. And during this project was the subject of this project was evading Suricata intrusion detection system. It was supervised by Philippe Antoine from Katana Cyber. And who is a Suricata developer and a teacher at Telecom Nancy. So firstly, what is an evasion? An evasion is a technique that prevents the detection of attacks. And when it is applied to network IDS, is the fact that the network traffic matches the semantic of a pool, but for example, Suricata does not raise an alert. And when it's the case, there are fewer logs, and so to avoid this, we can at least mitigate simple evasions.
So the SMB protocol stands for server message block and is used to share resources, for example, files or printer over a network. It can also be used to do some inter-process communication. There are three specifications for it: CIFS, SMB, and SMB2 from Microsoft. The first two are for SMB version 1, and the last is for SMB version 2 and version 3. And so the first two and the last one are very different. There are two main implementations of SMB servers, the one from Microsoft and the one from Samba, which is also an open source software. We chose to study this protocol because there are a lot of vulnerabilities associated to it. For example, the one used by Eternal Blue or the WannaCry ransomware. And another one, which is more recent, called SMB Ghost. There are three ways to send SMB messages, over TCP, over NetBIOS, or over remote direct memory access. So for SMB v1 over TCP, every message starts with a null byte. It is then followed by a message size, FF byte corresponding to version 1, and SMB. Those 4 bytes are a magic number, and it is then followed by a header and a payload. And the payload can consist of requests and responses. And they can be batched messages with index commands. So when index commands are used, it forms a chain, and the chain is then parsed by iterating the messages. In our threat model, client or server can perform evasion, but not both, because in this case, the client and the server can just agree on communicating with another protocol, which is not parsed by Suricata, and then it is simply evaded. And for this project, Telecom Nancy provided us with a cyber range infrastructure, which is like an hypervisor and a virtualized environment for creating networks. We chose to focus on SMB-v1 over TCP and client-side evasions. So it means client-side evasions that are performed by the client. And in our network topology, we used a Debian client, a Windows server, and two Suricata instances version 5. The first one is provided by the official repositories, and the second one is a development version used to test switches. To perform evasion, we can develop a SMB client from scratch, but this is a very complex and time-consuming process. Or we could alter SMB traffic on the fly with a proxy. And in this case, we can reuse an existing SMB client. So we chose the second solution. And we wrote some proxy rules to alter the traffic and test our evasion techniques.
So now I will speak about the file transfer evasions. So in order to perform this evasion, we use the file ECA, which is a common standard antivirus testing file, which is not malicious and just used for testing purpose. Then we use this rule to detect the ECA file through the network, and the content in just the bytes value of the ECA file. So the purpose of the evasion is for the client to send the ECA file to the server, but without alert from Suricata. So firstly, we tried fragmentation. Fragmentation is a common evasion technique, which is the fact that we have a standard TCP packet with a standard TCP packet, and we divide it into several pieces and send it to the server in several pieces. For example, for an SMB packet, we can just divide the NetBIOS packet and send it to the server, and then send the SMB ports and send it to the server. But we could also do some more complicated division. For example, to make several pieces of each messages, which with different sizes, and we can go on and send many packets with different size. So this technique was we did not found any evasion with this technique. Then we tried to merge two different NetBIOS messages in one TCP packet, because the Microsoft SMB server can parse these two different messages and process them. And we wanted to know if Suricata could do the same and analyze these two messages in a separate way. So we just merged these two packets and sent them to the server, and it appears that Suricata was not evaded, and so it could analyze these two pieces of the packet.
While reading the SMB-v1 Rust, we spotted two variables with an underscore prefix, and it is a common naming convention used in coding for unused variables. In this case, it's index command and offset, and those two fields correspond to the next command in the index chain to parse. So if Suricata does not use those variables in the code, it might not analyze the next messages in the chain. So we had an idea which consists of chaining another index command to write requests, but without making side effects. And according to the SMB specification, only the looking command can be used before write command. So we looked for some parameters for looking commands that would not make side evasion, and we prepend every write request with a looking request. And so in this case, Suricata was evaded. For the next evasion, we saw a data offset field in the write index request structure, and it corresponds to the number of bytes between the SMB v1 header and the file payload. So for the SMB client, it is almost always 64 bytes. So we try to add some padding between the SMB header and the data. For example, here 4 bytes of padding, and we updated the data offset to 68. And in this case, Suricata was also evaded because it was not computing the padding correctly. But these mistakes also happen on Wireshark, because we can see that the padding is considered as file data, but it should be in the padding field. So Suricata was evaded, and the same issue is present in Wireshark. When sending text to the server, we can send it only once, for example, SuriCon 21, or we could send first some random text, for example, a lot of A's, then overwrite it with our wanted text, SuriCon 21. So in the server side, the file is now SuriCon 21, but Suricata does not support the overwrite of data. So it allows to write the ECAR file or any file without detection, and this is also an evasion.
And now we present the final evasion we tried. So while we read the Suricata documentation, we spotted some SMB v1 keywords like SMB name pipe, which corresponds to the tree connect index request. And we wanted to test if the keywords were well analyzed by Suricata. So we used this rule to try this evasion. And so we tried to encode the string with a different another encoding method. So in the typical TCP SMB packet, there is an header which is a Unicode flag, which tells if the string is encoded by Unicode. So the idea is to flip its values and change the name pipe encoding. And for example, in this case, the string is encoded in Unicode, but in the following case, the string is encoded in UTF-16, and we wanted to know if Suricata could read the right string. So it appeared that Suricata was not evaded with this simple evasion. So to conclude, we used proxy rules to test evasion on the fly. We managed to find and we reported 3 SMB-v1 evasion. And for each technique we tried, we record network backups, in order to prove our tests. And we put some Suricata verify tests to the repository in order to have anti-regression tests. And we could what could we do next? For example, it could be to test more evasion on SMBv1, of course, but also to test server size evasion or evasion in SMBv2 or v3, and also test with other protocol, but with the same techniques. And thank you for following our presentation. We join you in live Q&A session to answer your question.